Have you ever wondered what the next giant leap for artificial intelligence is going to be? Well, what if I told you it isn't on Earth at all? Today, we are diving headfirst into a really radical idea from Google's research labs, one that could literally send the future of computing into orbit. Okay, let's just start with a huge question. I mean, think about it. If your mission was to build a computer powerful enough to tackle humanity's biggest, thorniest problems, we're talking everything from climate change to discovering new medicines, where would you even put it? The answer, according to some of the sharpest people over at Google, is, well, it's surprisingly simple. And at the same time, it's unbelievably ambitious. You'd build it in space. And nope, this is not science fiction. This is a real research project, a moonshot they're calling, Project Suncatcher. And the whole idea is to give artificial intelligence a radical new home, way up there. And you know, the motivation here is just massive. The researchers themselves say that AI is a foundational technology that could literally reshape our entire world. So that leads to the obvious next question. Where can we go to unlock its absolute 100% fullest potential? So what is Project Suncatcher really? Let's break it down. In the simplest terms, it's a plan to create these big groups of satellites, these constellations, and each one is going to be packed with Google's super powerful AI chips, their TPUs. And the whole thing would be powered directly by the sun, with all the satellites talking to each other using lasers. It's like a giant floating solar-powered data center just orbiting the Earth. But why? I mean, why go through all that trouble? Why on earth would you build a data center in space? Well, the answer really comes down to one single, massive, game-changing advantage: tapping into the ultimate power source. Okay, now this is where things get really, really interesting. A solar panel placed in just the right orbit can be up to 8 times more productive than the exact same panel sitting down here on the ground. 8 times! And this slide right here shows you exactly why. Down on Earth, solar power is, well, it's fickle, right? You've got clouds, you've got nighttime, you've got weather. But in a specific, carefully chosen orbit, you get near constant, totally unobstructed sunlight 24/7. And what that means is you need way fewer heavy, expensive batteries, and you get this continuous, clean stream of energy to power all that AI number crunching. Okay, so the vision is absolutely incredible, but let's be real. The engineering puzzles you have to solve to get there they're on another level. There are basically 4 huge hurdles that Google's team has to clear to make any of this a reality. Puzzle number 1, communication. See, for a big AI system to work, all the different chips need to talk to each other at insane speeds, just like they do in a data center on the ground. We're talking tens of terabits per second. How in the world do you do that with lasers between satellites that are flying through space? And would you believe it? They've already had a huge breakthrough. The secret is flying the satellites in a really tight formation, just a few kilometers apart. By doing that, they've already shown in a lab test that they can hit 1.6 terabits per second with just a single pair of laser transceivers. That is a massive, massive step forward. But of course, that leads directly to the next totally mind-bending puzzle: orbital dynamics. How on earth do you keep a big, dense cluster of satellites, we're talking maybe hundreds of them, flying just a few hundred meters apart without them all just drifting away or, smashing into each other? And here's the wild part. The laws of physics are actually on their side. If they choose a very specific path called a sun-synchronous orbit, their models show the whole constellation just stays remarkably stable all by itself. Pretty cool, right? Earth's gravity does most of the heavy lifting, and the satellites only need to fire their little thrusters every once in a while to stay in perfect formation. So, you can get them into a stable formation, but can the computer chips themselves actually survive up there? I mean, space is a pretty brutal environment. It's just filled with radiation that can absolutely fry sensitive electronics. So they tested it. They took their latest TPU chips and just blasted them with a proton beam to simulate years and years of radiation in orbit. And the results? They were fantastic. The chips only started to have problems after getting hit with almost 3 times the radiation they'd expect in a 5-year mission. The team's conclusion was that these chips are, and I'm quoting here, surprisingly radiation hard. Okay, so the physics works, the hardware can survive, but what about the biggest question of all? The money. For decades, the sheer cost of launching anything into orbit has been the ultimate showstopper for ideas like this. But you have to look at this trend line. This right here is the game changer. Thanks to the whole revolution in reusable rockets, launch costs are just plummeting. The projection is that by the mid-2030s, the cost to launch 1 kilogram could drop below $200. And at that price, launching and running a data center in space actually starts to look economically competitive with just paying the energy bill for a similar one down here on Earth. So, with these 4 huge puzzles all showing these incredibly promising solutions, this whole project is starting to move from just a theoretical dream into a potential reality. So let's take a look at what's actually next for Project Suncatcher. Now, of course, there is still a ton of engineering work to do. You've got things like managing heat in the vacuum of space, making shirts reliable for years. The next logical step is to tackle these problems head-on with an actual prototype mission. And this isn't some far-off, distant dream. They just published their research this year, and they are already partnering with the satellite company Planet to launch 2 prototype satellites by early 2027. This thing is moving from the drawing board to orbit in just a couple of years. It's happening fast. You know, Project Suncatcher isn't just about a new way to build a data center. It's a fundamental rethinking of where our most powerful tools should even live. And it forces us to ask this really profound question. As we build these ever more powerful artificial intelligences, is their future going to be written here on Earth, or is it going to be coded among the stars?